This tutorial is going to talk to you about the law of sines and cosines. So I first of all want to introduce this topic by bluntly writing out the law of cosines first. We will then proceed to the law of sines. So here's the law of cosines. And here it is. And it's intimidating, but I'm going to walk you through this little by little so that you understand what we're doing. The reason why we have a law of cosines is, let's say we wanted to know the side lengths of a triangle, and specifically in this case the hypotenuse. When we have a triangle and it has a right angle, we can find any of the missing side lengths by using Pythagorean theorem. We've also learned that we can use trigonometry to find certain values by using SOHCAHTOA. But all of those relate to triangles with right angles. So what about in the instance of a triangle that does not have a right angle at all? Well, this is where the law of cosines comes in to help. So here's a picture of an obtuse triangle. I'm sorry it's not perfect, but I tried. We have three sides, and with those three sides we have angles that correspond to them. So in the law of cosines, if you look up here in the formula, you see three lowercase letters, A, B, and C, and then out to the very, very right, we take the cosine of capital C. Well, what's the difference? I'm going to show you. If I want to run this triangle and label the sides, I would label them in lowercase letters. So A, and if this works for me, there we go, B, and then C. Now, if I want you to look at side A, it has an angle that corresponds to it, and it's directly opposite of it. So that means this angle right up here would be capital A. And angle B would be directly across from side B, so this is angle B. And capital C is going to be this guy right here. So that's where all the A, B, and C parts come from. And it does kind of look like the Pythagorean theorem, particularly the first three terms, c squared equals a squared plus b squared. That in itself is the Pythagorean theorem. What this last piece does right here is takes away the part that would make up that right triangle. Okay? So let's take a look at an example and see how we can use this. Okay, so here's a picture, and in this case, I know this angle that is directly between the two sides that I know. That is very important. Whatever angle that you have given, it needs to be between two sides that you already know. Whatever angle that happens to be is going to be little c. Okay. Capital C. And the side opposite that would be little c. So here's big C, and this would be little c to x. And it does not matter which side is A or B. So this will be A, and the 3 will be B. Okay. Now, in order to find the missing side, I have to use my law of cosines, because it helps me determine a missing side or a missing angle even, as long as I have these three pieces of information. So I'm going to set it up like such. So c squared, that's the part that I don't know, and that has an x in it right now. So I'm going to write x squared equals, and actually I'm going to write this out to the side because I'm going to run out of room. So x squared equals, now we come to a squared, and a squared is 5, so 5 squared plus b squared, and b in this case is 3. And I'm going to subtract 2 times a, which is 5, and b, which is 3. And I'm going to multiply that all by the cosine of 135 degrees. Let's see if this fits. Yes, it does. Awesome. Now, the manner in which you PEMDAS this is very important. You can actually input this entire term into your calculator just the way that it looks, and you should be okay. But we can maybe look over that in class just take this one step at a time. Eventually what I get, after some simplification, is x squared equals, let's see, 5 squared would be 25, 9 squared is 9, so that gives me 34, minus 2 times 5 times 3, which is 30, and in my on my chart, I know that the cosine of 135 degrees is negative square root of 2 over 2. Okay. Now, once I compute all of that out, then I get 55.213. Now that is not my final answer. I still have to square root both sides. And when I do, I have x equals 7.431. And when I look at my picture, make sure that this makes sense. It definitely does look much longer than either side, and at about the same amount. And that is how we can use the law of cosines. And here's the law of sines. And what the law of sines says is that all of the sides and their angles that I showed you before, all are proportional. So the sine of capital A, that angle, over A, is equal to the sine of B over B is equal to the sine of C over C. And we're going to take a look at an example so you can see how this works as well. So let's take a look at this example. We do have a triangle. There are no right angles. And I want to solve for x. So we want to try to find some kind of relationship. And I do see that I have a side that goes along with the 40 degrees. Right opposite of 40 degrees is the 0.5. So the way I'm going to use this is I'm going to set this up like so. I'm going to say the sine of 40 degrees over 0.5 is equal to, now let's take a look at the part that we need to look for. I'm looking for x, and that represents the side. So I'm going to put x down here. And the angle opposite that is 20 degrees. So sine of 20 degrees. And to solve this kind of an equation, this is a simple proportion, and I can cross multiply. So let's go ahead and do that. I'm going to do x times the sine of 40 degrees. So x times the sine of 40 degrees equals, and then I'm going to multiply the other pair. So 0.5 times the sine of 20 degrees. Now, on the left-hand side, I'm going to do x, and then I'm going to determine the sine of 40 degrees, which is 0.642. And then on the right-hand side, I'm just going to compute everything out together. So 0.5 times the sine of 20 degrees, which is 0.171. Now I have one less step to solve for x, and that is to divide both sides by 0.642. And that gives me x equals 0.266. And at this point in time, if I wanted to, I could determine the side opposite of 120 degrees as well, which we can call y, because I would be able to do the same kind of proportion, just set up another piece. So equals the sine of 120 degrees over y. So you can do this any number of ways that you'd like. And that concludes this tutorial.